Hello, dear students. Today we're going to demonstrate Proposition 5 of Book 2. Proposition 5 of Book 2. If a straight line be cut into even and uneven parts, the rectangle contained by the uneven parts plus the square on the points on the line between the points of section, which I'll explain, is equal to the square on the half. Okay? Before we get started with this prop, just remember that in this, well, first of all, remember that this book 2, is about lines. And what you do is like I showed in a couple videos ago, we're going to say something that's done to this line, and we're going to say, oh, therefore it's true. For example, in this case, if you have a straight line, and you cut it in half, and you also cut this very same straight line into uneven parts. So if you cut this line into even parts, and you cut this line into uneven parts, see that? Okay, now we're going to say what's true about it. So here, to make it easier for you visually, look at this is the same line now with colors. Here's the line, here it is, cut in even parts. The solid line and the dotted line are the even parts. And now it's cut into uneven parts. The uneven parts are the blue line and the red line. And what we're going to show is that if you do that, then the rectangle contained by the uneven parts plus the square on the line between the points of section. You see how it's been cut twice? Even parts and uneven parts. And you have a line between the points of section. So if you do that, then you say the rectangle contained by the uneven parts plus the square on the line between the points of section will be equal to the square on the even part. Okay? Let's make one other reminder here. Remember, when you have a square, you have equal sides and right angles. So if you have a line, you can only have one side of square. That's it. Once you have a line, that's your square. The square is not going to be like this. It's going to be something like this. It's going to be something like this because same equal sides and right angles. The same thing with a rectangle. Remember, a rectangle has right angles too. Once you're given two lines, you necessarily have the size of your rectangle. It's going to be that size, or more or less. It's not going to be this size, because this is way too big, okay? So now that you have your lines, you necessarily have your rectangles and your squares, okay? So, let us make a square on one of the even lines. Remember, even lines here, solid and dotted. Let's make a square on one of the even lines, okay? We can do that. Let's do that like this, say. Drop a right angle, okay? Drop a right angle. Let's do this one with green as well, I guess. The right one. Okay? Más o menos. Try to make it look good for the imagination so the intellect has a good time, okay? Then we connect these 2 points. Great. Now, let us draw the diagonal. So now we have the square, right? Equal sides, right angles. Now we're going to connect the 2 points, and that's called the diagonal, or the diameter, remember. This is called the diameter. Great. Now, let's draw a parallel line, a line parallel to either side. Okay, we can do that. That's no problem. We know that given a line and a point not on that line, to draw a line parallel to that line. That's no problem. Great. Now, at these cross sections, from that point, we're not going to go from here because we don't know if it's going to cross through. If we start from that point, we can draw a line parallel to this line. Given a line and a point not on it, to draw a line parallel to the given line. Great. Now, what color do I want this one in? Blue. Let's just continue the line then. Now, this is parallel to this, and this is parallel to this and this. Great. And you see we have our square. Great. Oh, look what we have here. Complements. We know complements. Sorry. Let's make a rectangle here. Okay? Right angles and continue this on. And let's do it in a different color. Let's do it in orange. Continue this. Drop this down. Great. Worked out perfectly. Right angles, etc. Okay? Great. Now let's color some stuff in to make our life easier. Okay, let's do this stuff in this stuff in. Green. Let's make our complements green. Let's make our square on the uneven part. Oh, by the way, these are parallelograms, so, and we know they're squares. We'll prove that they're squares in a second. Let's make this little chunk red, and this chunk blue. Okay? And we'll make this chunk orange. Just make it, we won't even color it in. Right. So what do we have here? Remember, it's about lines. We make our figure, then we show chunks equal to chunks, and then we show, hey, those chunks which are equal, there are the square on this line and the rectangle on that line. Okay, so let's do that. Look at this square here that we made. And it's a parallelogram. Squares are parallelograms también. So we have the complements of the parallelograms are equal. Okay, so here's our parallelogram and here are the complements. This is equal to this. Great. Let's add equals to both sides. Therefore, let's add this to both sides. This plus this will be equal to this plus this, because equals added to equals are equal. Therefore, you have this being equal to this, right? That's no problem. Uh-oh, but look at this and this. Here you have two parallelograms on equal sides, on equal bases, and in the same parallels. Therefore, they're equal to each other. So this is equal to this, okay? But this was proven equal to this, remember? Therefore, two things equal to the same thing are equal to each other. If this is equal to this, and this is equal to this, this is equal to this. This is equal to this. Great. Look at that little thing right there. Let's add that to both sides. If this is equal to this, we'll add that to both sides. Equals added to equals, the wholes are equal. This whole thing will equal this whole thing. And that, by the way, is called a nomen. You can look at that up in your definitions in the book. This thing right here is called a nomen. So this big old thing is equal to this nomen. Great? Look up what we have here, something we can add to both sides. If this is equal to this, and we add this chunk to both sides, you have this plus this is equal to this plus this. But this plus this is this big old square. Great. So now we see that this plus this is equal to this big old square. Great. But this big old square is the square on the half. Okay, so then this plus this is equal to the square on the half. But this is the square on this line. By the way, how do I know that these are squares? I got to prove that. Remember how we proved that before? You show, got parallel lines and a straight line falling upon them. You show that, therefore, the angles are equal. Okay, this is equal to this. And you know, likewise, this is going to be equal to this because parallel lines, therefore, the exterior angle is equal to the opposite interior angle, something like that. So this is equal to this. But this is equal to this. Therefore, they're equal to each other. Therefore, that's equal to that. Okay? But this was made a right angle. Therefore, this angle is equal to that. And this is opposite of that, the parallelogram, so it's equal. So, and that, likewise, that's equal. So you have everything equal and everything right angled. Therefore, this is a square. So this chunk is the square on this line because this line is equal to that line. Remember, once you're given a line, you can put that square wherever you want, and it is the square on that line if this is equal to that, and it's at right angles. So this is equal to the square on this line. Now remember, a long time ago we said that this big old thing plus this chunk is equal to this chunk. And then we showed that this chunk is the square on this line. And now so therefore this big old chunk and this chunk is equal to the square on this line. But we show now that this chunk is the square on this line. So this chunk plus this chunk equals the square on this line, and this chunk is the square on this line, which we showed. Then you can say that this chunk plus the square on this line is equal to the square on this line. But look at this big old chunk. It is the rectangle contained by the uneven sides, because this being a square, we can prove that the same way we prove that this is a square. This being a square, this is equal to this. This rectangle is made by these lines. And that is to say it's made by these two lines. Remember, when you have two lines and a right angle, you necessarily have your rectangle. Here's our two lines. And here's our right angle, therefore we necessarily have our rectangle, this. But this line is equal to this line. So here's our two lines, and this is the rectangle. So this rectangle is the rectangle contained by these two sides. But these two sides are the uneven lines. Therefore, the rectangle contained by this plus this and the square on this is equal to the square on this. But the rectangle contained by the square, by the this and this, is the rectangle contained by the uneven lines. And the square on the line between the points of section is the square. So we have the rectangle contained by the uneven lines plus the square on the line between the points of section is equal to the square on the even line. Quod erat demonstrandum. Sorry, let me say it again now. Therefore, you know that if you have a line and you cut it in equal parts and unequal parts, the square on the equal parts, on one of the equal parts, will be equal to the rectangle contained by the unequal parts plus the square on the line between the points of section. Okay? There, let me say it one more time. If you have a line and you cut it into equal and unequal parts, the rectangle contained by the unequal parts plus the square on the line between the points of section is equal to the square on the half. Quod erat demonstrandum. Thank you. Bye-bye.